All right, good afternoon, everyone. We're gonna get started on time. First of all, thanks very much for coming in and hanging around this late. Thanks for coming to the session. So this is a 200 level introductory session to real-time streaming data analytics and applications on AWS. My name is Ray. I do product management for Amazon Kinesis. Super excited to be here and see the crowd and see the energy. All right, so we're really here to answer a few key questions. So hopefully you guys are here for some of these questions or for the answers to all of these questions. So first and the most important questions to answer is, why should I care about it? Why should I care about real-time analytics? I'm pretty sure every single one of you guys and for your companies, you have some sort of data analytics pipeline and solution, and most likely they've been there for many years and they work out just fine. Then why should I care about this new thing and invest engineering effort to this new technology? Why should I care about them? Second thing is, real-time analytics sounds very great, sounds very awesome, but what really is real-time data? I've heard of application data, log data, clickstream data, but what does real-time data really mean? And what kind of data can I use real-time technologies to analyze and stream them? And third question is, of course, what kind of capabilities does AWS offer to help me get started quickly and help me run these applications and take away all the complexities, and what kind of things AWS has to offer to help make your life a bit easier in terms of real-time and streaming applications. The next question is, Kinesis service has been in the market for a bit over 3.5, 4 years. We've had a lot of customers using the service, so I want to share a few examples with you guys. How are these different customers across different industries using their imagination, using real-time technology to either change their customer experience or change the way they run their operations and applications? And lastly, I'll touch upon a few typical patterns we've seen from the customers using real-time applications on AWS. What are the common architectures for different kind of use cases as a reference for you guys? Then lastly, we should have some time for questions. You guys, feel free to answer. First, why should I care about real-time analytics? What is this new thing? What value does it bring to the table? And why should I invest my time to do this? Well, first, because real-time sounds really awesome and really cool. And that's not why you should care about real-time analytics. At least that shouldn't be the only reason why you should care about real-time analytics. Now I'll give a concrete example, a day in the life. Any folks here who run a website or has a component of website or web services in your core business? Great, thank you. And a vast majority, and for those of you who do not have a website component, you probably have experienced this error as a customer. So this is a very unpleasant error message you're gonna see from time to time from your web browser when you're trying to access some content or information, but you just couldn't get to it. It says 500 error, internal error, it doesn't tell you anything. Something's wrong on the web server side, on the application. You're frustrated. You probably get a very unhappy customers trying to get to the content, but couldn't really get to it. Now, once that happens, you'll probably get a call from a customer through a customer service group. Then the operational engineer or the dev engineers, the manager will get a call and call the person who's on call to figure out the issue. Then the first thing the engineer is going to do is you're going to go to your log system, trying to dive into the logs and figure out what has gone wrong. If you have a relatively mature log system, you probably have a centralized location, have the logs from hundreds of your web servers stored in a central place to look at. If you're not, then tough luck. You might have to go through every single one of these web servers and try to figure out which one has the issue by pure chance. If you're lucky, you might get to the right server who's having the issue at the 100th try. If you're unlucky, you might be able to find it at the 500th try. That takes a lot of time. And in terms of a centralized logging location, then dev engineers log into the server, look at all the log data, and everything shows up as 200 code, which means everything works out perfectly fine. And you get really frustrated. You couldn't figure out why, not to say that, how do I fix that issue? On one hand, you have a customer waiting online, your service is down, it's impacting your customer experience and business. On the other side, as an engineer, I just can't figure out why. Then you take a closer look. Actually, these log data is really old. They were from 1998. I'm exaggerating a little bit. It's not really from 1998, but you get a point. So oftentimes you have an issue. You get onto your logging server, take a look at the log data, but the data doesn't show up minutes, hours. You just keep waiting and they don't show up. It gets really frustrated because you cannot get access to these data as soon as they're generated. When an issue happens, you don't have real-time insights into what has gone wrong. So you get a pretty frustrated engineer on the other hand. So you've got an unhappy customer, now you got a pretty frustrated engineer on the other side. Couldn't really figure out the problem. So this is a pretty nice graph that I really like. It summarizes everything I have to say about the value of real-time analytics and why you should care about it. So on the y-axis, it's the value of the data, the value that you're able to extract from your data. On the x-axis, it's time. So you can see as time goes on, the amount of information and value you can extract from your data diminishes. And at some point, the data becomes stale and it's no longer valuable. So in the previous case, if today I can see only the log data from 1998, probably I've lost all my customers. I don't even have a business to run. So these data is no longer relevant to my business. All right, so what is real-time data? That all sounds great. Log data is one of the examples, but what are the other kind of data that I can access and analyze and react in real time? It turns out vast majority of the data in the world is generated in real time and continuously. It's just traditionally the technology for analyzing and reacting to the insights is built on a batch-oriented manner. So we didn't really think about what is really real-time data? So actually, most of the data is real-time data. If you have a mobile application, you run a website, these log data on our application gets generated real-time constantly. Clickstream event, when your users, your customers are interacting with your applications, websites, the behavior events data, they are generated constantly in real time. Metering, a classic example. In fact, that's the why we were motivated to build the AWS streaming technology at the first place. So you guys are all AWS customers. You use EC2 instances, S3, Redshift. Most of the services has a pay-as-you-go pricing model, so you only pay for price like elastically. You don't need to pay anything up front. So as you use all these AWS services, how much of EC2 you've used, how much of S3 you've used, each of the services generate metering data for us to figure out the pricing and billing later on to show you on the billing console. The entire thing, the metering pipeline, billing pipeline, is built on top of Kinesis, which was initial motivation for us to build this technology at the first place. Also, a lot of IoT use cases, sensors, temperature sensors, pressure sensors, humidity sensors. These data gets generated constantly. And you really want to figure out a way to be able to access, ingest, and analyze these data in real time. So in summary, actually, almost 99% of the data that you're dealing with today, you can think of, they are real-time data. They can be used by real-time technologies to analyze and gain insights and react to them much, much faster than what you do today. So real-time analytics data pipeline, what are some of the components? When you think about building a real-time application or a streaming data pipeline, what are the components, what are the requirements? So first is ingestion. It turns out actually getting data ingested in a centralized place at large scale in real time isn't a trivial problem to solve, and we've built a service to do exactly that. If you think about it, you run a large-scale website, for example, you might have 500 web servers. You need to constantly writing thousands of log lines into a centralized system from all these distributed web servers. If you run an IoT device, even more so. Like you might have millions or thousands of IoT devices. Every single one of them needs to communicate with a streaming system to collect these data off these devices in real time so that you have a centralized place to have all these data available for you to run analysis. Second one is transformation. A lot of the data is generated in a very raw format. It's not suitable for analysis. For example, log line just generated as a single log line data. You gotta have to break it up, convert that into some structured format for you to do calculations like sum, average, max, min. So you gotta have to be able to do some real-time transformations on the fly as the data is ingested through your pipeline. So that's the transformation piece. And of course, you're going to have to be able to analyze the data. So I have all these data. I have to do some computation, statistics, anomaly detection to figure out what kind of events that I want to respond to. So that's the analysis piece. And of course, reaction, because the whole point of having a real-time pipeline versus a batch pipeline with hours or days delay is you want to react to that faster. You know, given the previous example that I gave, in this case, you wanted the human being, the operator, to be able to figure out what has gone wrong faster from the logging system. But in some cases, you might have a case where you want to react with even lower latency requirement, like seconds or milliseconds. If one of my web server I've identified as having an issue, maybe before even I page my operators, I want to bring that web server out of my fleet and start up a new one so that the issue can be mitigated right away by a program versus a human being. In this case, we're talking about seconds or minutes latency without even a human being getting involved. After you bring that bad web server out of the cluster, then you can have the human being to do troubleshooting and figure out what has gone wrong. So that's the reaction piece. Then persist. I really think real-time technology is not meant to replace whatever you are doing today in a batch-oriented way. I think of it as a supplement, a complementary. So oftentimes, from what we've seen from our customers, they almost always have real-time and a batch. They go hand to hand. So you have a case where you want to have a real-time pipeline to do real-time analytics. Also, always you want to persist the data somewhere in a batch store like Amazon S3 for long-term historical analysis. I'll give an example later on so that you can see why you really need both of these two things to run a good user experience and operations. So these are the components, like what you need for a real-time streaming pipeline. But what are some of the requirements that we really try hard to deliver to our customers in our services? So durability. It's super important. Number one priority for us is we got to have to make sure whatever data you send to us, once we give you a 200 successful code, we never lose any data. So Kinesis Services has been in the market for more than 3 years. Since I joined the company, we've never lost any customer data, not even a single byte. So once we send data to the Kinesis service to AWS, it's durably and securely stored. We don't lose customer data. Second, it's continuous processing. So if you think about real time, if you guys are familiar with the traditional, batch-oriented analysis, oftentimes the key difference is about the time, because time becomes really tricky when you deal with a real-time system. In a batch system, time has a boundary, because when you run query, when you run analysis, you always define, here's a starting point of the time, here's the ending point of the time, and I want to analyze the data in between these two different timestamps. But in case of a real-time streaming system, new data keeps coming in. There really is no boundary for time, because time never ends. So really, in terms of time, it's continuous. What we are dealing with, we no longer have a fixed time boundary. We no longer have a fixed window. So you'll have some sort of a concept of a sliding or tumbling window where the boundary for you to analyze the data, that window keeps moving forward over time, and it's continuous. And of course, it has to be fast and reactive. So that's the entire idea, the whole point of streaming system to bring real-time analytics to life is you want it to be able to gain insights faster. You want it to be able to react to the insights faster so that you can make an impact on your user experience and business. And of course, it has to be highly available and reliable, because for a lot of customers running mission-critical pipelines that's tied into their core business, not only for log data, but some customers build their core application and business around a streaming pipeline. So every time if the stream's not available, their service is not available, their application is not available, their business is not available. So we got to have to make sure we have a highly reliable and available system. So for Kinesis, we run our infrastructures across 3 AWS data centers with data replication across 3 AZs by default. So we're highly available, reliable. Again, as I mentioned, the entire AWS metering and billing pipeline runs on Kinesis. So we are built for availability and reliability. All right, so next, that all sounds great. What are some of the capabilities AWS has to offer if I want to do some real-time or stream pipeline in my business? So Amazon Kinesis is the real-time streaming service group under AWS. Today we have 3 different services offering different capabilities depending on the different use case. Kinesis Streams on the very right-hand side is actually the first service we shipped 3.5 years ago. What it does is you can think of it as a high-frequency, real-time, replayable storage system for streaming data. So you'll configure your data producers to get data into the service. On the other side, you can actually have a replayable stream, have your consumers read the data, run your own applications, and process the data in real time. So that's Kinesis Streams. Once we ship Kinesis Streams, we learn from customers, a lot of the early adopters, they're like, most of the customers out there, they've been doing batch analytics for a very long time. They've been using a data warehouse. They've been using, say, EMR, Hive for a very long time, or they've been using a search engine like Elasticsearch for a very long time. They don't want to completely move away from these pipelines, but at the same time, they want to take advantage of these real-time technologies. Like, instead of having data loaded into my data warehouse every day or every hour, can I get them loaded in Redshift continuously with a few minutes latency? So we see a lot of customers building their applications for the use case of loading these real-time data into these different data storage and analytics destinations. Then we figured actually maybe we can just do that and make your life a little bit easier because you don't need to write an application or manage any application infrastructure. So we built a layer on top of Kinesis Stream, and that's where Firehose is coming from. So Firehose service is building on top of Kinesis Streams with an application for data delivery. So you push the data into the service. You don't need to know anything about streaming, processing, or application. The service will continuously push the data into the destination that is specified and handle all the error retry, backup, failure handling, and data transformation on the fly. Then we ship the Firehose, we looked across, we have a lot of customers writing their own applications on Kinesis Stream, doing very interesting things using Java and Python. But still, there's a lot of audience, customers out there, they're really excited about this technology. They want to use these things in their business, but they don't really have deep expertise in distributed system, in streaming technology, and writing the application isn't super easy at that time. So then we say, maybe we should do something to help our customers make their life a little bit easier for them to use these technologies. And that's when we shipped Kinesis Analytics. It's a SQL engine that abstracts away everything about streaming beneath, everything about distributed system. And it uses SQL language. We picked SQL because vast majority of the technical professionals, they have some sort of SQL language. So we figured if we can let anybody who can write a SQL statement can run a query against a live data stream versus a data warehouse and reduce the latency if we to analyze your data from hours or days down to seconds or minutes, that'll be really great. So we shipped this Kinesis Analytics. It's a SQL engine that allows you to run standard SQL continuously on top of a data stream versus a data warehouse. Again, what it does is instead of having hours or days latency, now you can gain insights and do analysis against your data with minutes or seconds latency. Super cool. So Kinesis Streams, I just want to dive a little bit deeper into each of these individual services. As I mentioned, it's a streaming storage system, sits in the middle. On the left-hand side is how you get data into the Kinesis Stream. So we have AWS SDK or mobile SDK. We offer REST APIs for you to call and put data into this service. So you can get data into Kinesis service from your EC2 instances, on-prem servers, mobile devices, IoT devices, and push these data into Kinesis through a RESTful API. We also offer a Kinesis agent. It's a Java-based application really targeted for cases where you have EC2 instance or Linux instances that are generating log data as a local file. What it does is it'll keep monitoring a directory of log files. And anytime when you have the new data or new log line gets written into these files, it'll automatically pick it up and forward that into the Kinesis service. Then also we have a lot of integrations with native AWS services. For example, CloudWatch Logs. It has VPC flow logs, Lambda logs. We have customers who want to analyze these log data in real time. You can actually use a subscription feature in CloudWatch Logs, hook up a Kinesis stream with it, so that anytime when you have new flow log data or Lambda log data or any log data gets written into CloudWatch Logs, it'll get forwarded into Kinesis stream automatically. We also have integration with CloudWatch Events. It has all these events generated by different AWS services. One of the most popular one is CloudTrail. So today you can access CloudTrail data through an S3 bucket with somewhere between 10 to 30 minutes latency. But all these CloudTrail events is also rendered in real time in CloudWatch Events. And again, we have a direct integration between Kinesis and CloudWatch Events. You can actually stream your CloudTrail data into Kinesis and run real-time analytics off it. We also have integration with AWS IoT. So for those of you guys who are familiar with IoT, normally these devices doesn't have enough compute and internet resource, connection resource. It's not feasible to run protocols like HTTPS. So there's a special protocol for IoT devices, which is MQTT, and the AWS IoT service does exactly that. And we have direct integration with AWS IoT to get IoT data through MQTT protocol over to Kinesis. And in fact, I believe AWS IoT just announced a pricing change yesterday or last week. When you do that, you'll pay significantly lower price on AWS IoT if you're not leveraging other capability and just use MQTT protocol. So even great for customers who want to use streaming technology, analyze their IoT data. On the other side is the consumption. So, we figure out the ways to get the data into Kinesis, but what are the capabilities I can leverage to consume the data and analyze the data? Because that's really the fun part. So, again, we offer, a pretty wide variety of different choices. The top one is Kinesis Client Library. It's a Java library we ship with a multi-land daemon that support other languages like Python. What it does is it abstracts away the lower level management of a distributed system. How do I handle different workers consume and process data off the same stream? How do I manage progress? How do I do load balancing? How do I scale up and scale down my consumers? It handles all that and abstracts that away from you. So you just write your own applications on top of this library and focus on the business logic, what kind of analysis you want to do against your data, versus think about how do I do load balancing, how do I do failover, how do I scale. We also integrate with AWS Lambda, so there's a direct integration. You can configure an AWS Lambda function to consume events from Kinesis. Super simple, super easy for cases like you want to do simple event-by-event transformation, filtering, or trigger an alert or trigger an action based on particular type of event. Lambda is super easy and straightforward. And if you use Lambda, the entire pipeline will be serverless, because all the Kinesis services are also serverless. You don't see any server, you don't manage any instances. And of course, we got a Firehose. If you recall, Firehose does data delivery into these different storage and analytics destinations. And you can actually attach a Firehose into a Kinesis stream. Use it as an application, a pre-built application we've done for you to ship data into these different destination and locations in near real time. And of course, we got a Kinesis Analytics, a SQL engine, allows you to run and build applications using SQL language and run direct query against the data stream. We also integrate with Amazon EMR. So for some folks who want to use things like Spark streaming to analyze the data out of Kinesis stream, you can also do that. It's Firehose. So as I mentioned, it's a service that ships data into these different destinations. We started with S3 and Redshift. Then we learned from customers. A lot of customers are using Elasticsearch, so we added support for Elasticsearch. And a few weeks back, we announced an integration with Splunk, because again, we heard from customers, a lot of customers using Splunk to analyze their data. They want to use the ingestion and streaming capability from Kinesis Firehose, so they asked for this integration, and we did it. And this integration is now GA officially, so you can actually go ahead and try that through the console. So what Firehose brings to the table is, as I mentioned, in this case, you still use the tools you've been using, a data warehouse, any visualization tools you have built on top of it, a search engine, Kibana dashboard you've built on top of it. You don't change that, but what Firehose brings to the table is you are able to access and analyze these data at a much lower latency so that you can gain insights and react quickly. Firehose also does all the scale, so you don't need to worry about that. You just keep pushing data to it. It's fault tolerant. If any of these destinations not available, it'll retry and keep the data for up to 7 days. And after retry duration that you configure, if the data is still not able to be reached, not able to reach your destination, it'll back up the data into S3. So again, that's for durability. We treat this really seriously. We don't lose any of your data. Even if your Redshift cluster is, for example, under resizing, not available for a few hours, we keep the data in the S3 bucket so that you don't lose any data. And if you realize, actually, within the Firehose icon, there's a square with a lambda in it. So we actually have integration within the Firehose service with a lambda function for you to do data transformation. If you recall, that's one of the key components for a streaming pipeline is a lot of time data is generated raw. I want to have a single system that not only does ingestion, but also does transformation and delivery. Classic example is customers who use Elasticsearch, for example, to analyze Apache log. So for those of you guys are familiar with Elasticsearch, it takes JSON data. So you got to have to transform your raw log line into some structure in a JSON format before you can ship the data into Elasticsearch. So Firehose is a single service that does that all. You can actually have your web service push Apache log data into Firehose service, configure Lambda function, transforms the data from a raw log line into a JSON document, and then Firehose will does everything and ship the data into your Elasticsearch cluster. We got a Kinesis analytics, so I mentioned a SQL query. This is a particular service we also work very closely with the AWS machine learning team to build a lot of machine learning algorithms into it. One classic example, which is super popular since we shipped the service, anomaly detection. So you don't need to be a machine learning expert. You don't need to know anything about these complicated algorithms, which I don't really understand myself either. But you just need to understand what it does for you. So the anomaly detection algorithm, it'll keep tracking the trend of the data events coming into the engine. And it'll assign a score of how likely this event looks like anomaly based on the pattern I've seen from the past. And you can react to that. One of the examples which I find is pretty interesting is we have a major airline customer. You guys probably know, like, one of the secret sauce of the airlines is their pricing engine. So when you search for a flight ticket, the price, every time you search it throughout different time of the day, through different days of the week, they keep changing. Because they have a pricing engine, that's the secret sauce for airlines to operate their flights. It's based on the searching patterns, number of passengers, number of the tickets sold, any events happening in the particular city and route. They keep changing the price. And from time to time, there's an error or there's a glitch in the pricing model or pricing engine algorithm. So you'll have an awfully high price ticket, which is not too much of a problem for the airline because you won't buy that anyways. And if you do buy it, good for the airline. But it's terrible for the airline when they have an awfully low price ticket, like you see a $50 round trip flight from New York City to Paris. That's terribly wrong. And the airline, the result is that they're losing tens of millions of dollars because of that issue on a yearly basis. So they actually, and that team, data analytics team, they do not have much knowledge about machine learning. So they hook up actually Kinesis analytics with their Kinesis stream, which they actually crawl all the pricing information from these different travel websites of their own flight ticket into a Kinesis stream and run an anomaly detection algorithm in Kinesis analytics. And it'll keep scoring the anomaly. And if you see a particular price point that looks pretty different from the price from the past hour, for example, it'll trigger a Lambda function, send an alert to the operator, and bring that ticket offline. So as a result, that's saving a lot of money, like tens of millions of dollars as a result of that. Again, just want to illustrate, it's super easy to use because you don't need to know anything about a streaming real time or machine learning. It's a simple algorithm that helps you to completely change the way you operate the business and ticketing system. As I mentioned, we also have other use cases like continuous filtering, aggregation, which is another common use case when we have customers who ship data into a data warehouse, a search engine, or Splunk. Oftentimes, when the producer, like a logging server, they generate a huge amount of data, like Every second, you might have 500 different log lines or have 200 successful code. And you don't need all of these information in your warehouse or search engine because that'll cost money for storage on the destination. So you can actually use Kinesis Analytics with very low cost to pre-aggregate these data before you ship these data into a data warehouse or search engine. So you can reduce actually these 500 log lines with the same successful code into one, and say count of these kind of log lines is 500. So instead of sending 500 records, now you send one without losing any information that you care about. So the key point for the Kinesis SQL engine, Analytics SQL engine, is the keyword is continuous, as I mentioned. A continuous query doesn't have a time boundary. You specify a window, a time window with a fixed bandwidth, and it'll keep moving. You can specify a sliding window, a tumbling window. It'll continuously run the query, and as the time moves on. Another keyword is SQL. So it's super easy. You don't need to know anything about Java, Python. As long as you can write a SQL query, anybody can go on and play with it and gain insights out of your data stream in real time. So we also have a lot of third-party partners. Since we ship these services, we actually have a lot of third-party companies. Some of them are partners building their connectors ecosystem around Kinesis. These are just a few examples. So I just want to demonstrate that actually we have a pretty rich ecosystem, and these are just a selection, and we'll keep expanding. Apparently, these companies and the partners, they find a lot of value leveraging the Kinesis capabilities for their customers, which is why they're building these connectors around Kinesis. Okay, this is the fun part. Who used them? What are some of the examples? So you've talked about a lot of that stuff. It all sounds great, but can you give me a few concrete examples? Sushiro is my favorite example. Actually, before that, we have like a wall of different logos from the customers. We have pretty diverse customer group. You can see from this slide, we have startups, mid-market, enterprise across different industries. Real estate, digital marketing, entertainment, real estate, manufacturing, retail. So pretty diverse across different industry segments for different kind of use cases. Now, a particular use case is Sushiro. So if you've been to any of my talks before for AWS Summits or any Loft events or any re:Invent sessions before, you've probably heard of this, but I just love it so much, I can't stop talking about this use case. It's super cool. Sushiro is a rotating sushi bar restaurant in Tokyo. It's a chain. Have you guys been to one of these rotating sushi bars where you pick up the plate and eat it yourself? Now, I personally find there are two moments that I find it really frustrating when you sit at a rotating sushi bar restaurant. First thing is, you pick up a particular dish, a particular sushi, you tried it, you really like it. Either you want to try more yourself, or you want to have your friends try that as well. Then you just keep waiting, and it never comes back. And apparently that's the only one that you can get. You just keep waiting, it never comes back. Super frustrating. And the second case is when you pick up plates, so you pick up a salmon nigiri, and it's actually the salmon's already dried out, and the color turns into darkish color. Apparently it's been on that belt for a very long time. It's no longer fresh, and you really hate it. I mean, it's just not the best experience you can have as a customer. So this restaurant, they're really ahead of their competitors. They come up with a super cool and really innovating solution. They put a sensor under each of the plate they put on the rotating belt for their sushis. The sensor does a few things. First, it keeps tracking anytime when a particular plate gets picked up by a particular customer, they collect that event, going through a Kinesis, trigger an application, send the information back to the kitchen, and tell the chef, you gotta have to make another one because the customer has picked up this particular plate, you gotta have to refill. Another thing it does, it'll keep tracking the time the plate has been put on the particular rotating belt. And past a certain threshold, they're gonna dump it. So you will no longer have an unfresh sushi get picked up by you. And at the same time, this is a real-time flow to run their operations, have a much better customer experience. But you might also be wondering, all right, that's great. I'll keep tracking time, great customer experience, but I might end up dumping a lot of sushis, and that'll increase my cost. They also send all these data from Kinesis into Redshift as a long-term storage for historical analysis. Because not only you want to see what's happening right now, You also want to figure out a historical trend on a monthly basis or on a weekly basis across different seasons, different days of the week. What are the patterns? How are my customers consuming sushis? How many of them I should make at a particular point of time so that I can run a much more efficient operations, not end up wasting a lot of the food and increase my costs. So this is exactly the reason why I mentioned actually I really think real time and a batch historical analysis, they should go hand in hand because you will find a use case for both. Particularly, it'll be super powerful where you can join the insights with historical data and real-time data, which is super helpful for example, anomaly detection, because you can only know whether the current event is not abnormal if you know what's the normal. And normal always comes out from historical data. So really, these two things will go together. Real-time flow, historical batch flow, and at Kinesis, we offer these capabilities for you to do both. The next example is our very own Amazon Game Studios. I don't know if there are any gamers here. I'm pretty sure there are quite a few gamers here. So this game called Breakaway. If you play video games or have played video games at some point of time, it's actually really hard to please a diverse set of gamers. Because on one hand, you can't really make the game too easy. Because it's too easy, it's not engaging. You don't feel like you're being challenged and you don't feel like you're satisfied by complete these challenges. So it can't be too easy. On the other hand, it cannot be too hard. I don't know if you guys have been stuck with a particular game at a particular boss or a stage for a very long time, just couldn't get through, then you give up. Screw it, I no longer want to play this game because it took me so long, I just couldn't beat it. So that's a really hard problem. So this is a particular scene in this game developed by Amazon, where different players can get online, they can fight with each other, they can fight the boss, these AI robots designed by the game. So they want to figure out, hey, which area on this map is too hard and which area is a little bit too easy so that I can adjust the AI robots' difficulties across these different areas. So they end up collecting these data using Kinesis and develop a heat map. So they keep ingesting every single time when a player dies on a particular point on the map, they emit an event into Kinesis. And they keep tracking that. And behind the scene, they have a dashboard to generate a heat map to figure out, in this map, you can see actually in the center area, apparently a lot of the players are fighting pretty hard AI robots, and they die quite frequently. And on the other hand, in the surrounding areas, they are less likely to die. So you can adjust the difficulties of these AI robots accordingly in the game to provide a much more engaging experience. Netflix. Pretty sure we have a lot of Netflix fans here. Stranger Things, in case you guys don't watch it, highly recommend it. It says season 2 just came out. So you guys probably all know Netflix run their infrastructure on AWS. So you want to make sure your infrastructure, your applications are really reliable and secure, so that you can constantly deliver these content to your end consumers without any issue. So Netflix has a huge infrastructure presence on AWS, run their entire application and content. So you have to make sure, as an engineer, as a company who operate that business, these infrastructure, have a closer look on the accessing patterns within their network. So AWS has a capability called a VPC flow logs. So it keeps tracking the network access across your different assets, different instances, buckets, across different VPC networks, so that you can gain insights. Anytime you see a suspicious traffic or abnormal traffic across two different instances, you know either something's wrong with your application or somebody from a suspicious IP address is accessing some of your core instances or constant. You gotta have to block them. So they actually use Kinesis streams to collect all the VPC flow logs to stream them, and they build their own application, including a real-time dashboard piece to keep analyzing these patterns. So anytime if you see anything abnormal, you'll you will notify an engineer to come take a look at it. Anytime you see an IP address looks pretty suspicious, you'll shut down the traffic from that IP address. So this way it allows you to be able to react to these patterns much, much more faster, versus you'll wait until a service is having issue, then you have somebody to go take a look at it. Now you can react on the fly in real time and have a much more reliable and secure service to offer to your customers. So these just like a hand of experience, customer examples that I personally really like. We have a lot more customers, as I mentioned previously from the slide. Now, hopefully, after these examples, more or less, you guys, get a little bit of inspiration to think about, hey, it seems like, different companies, different industries, they can all take advantage of these technologies. What are the things I can do for my company? Either provide a differentiated customer experience or provide a much better operations, make my engineers' life a little bit easier in terms of troubleshooting and run the service and run the application. And there are a few common patterns we've seen since we ship these services from these customers. The first one is real-time application. So this graph really demonstrates the idea that I mentioned. There's a term called a Lambda architecture, not AWS Lambda, but if you search for it, Lambda architecture really refers to an architecture where all of your data pipeline will have a real-time component and a batch component. They go together. You'll have a real-time insights application. You'll also have a batch flow for long-term historical analysis. So we have a lot of customers doing this architecture. They use the Kinesis streams up front, and they use consumer applications. In this case, it's the client library. You can use a Lambda function. You can use Kinesis analytics. You can use Spark streaming to analyze the data in real time, gain insights, take real-time reaction. At the same time, attach a Firehose delivery stream onto the same Kinesis stream and ship the data into S3 in near real time for historical and batch analysis or simply persistence. So that's another thing you can see from the streaming. A question that we often got, I think I explained here is, hey, what's the difference between a stream and a queue? Because we know queue quite, a lot of people are familiar with queue. What are the differences? It sounds like pretty similar. Well, queue, the key differences that are for queues, you write the data once, you consume the data once. Queue is really for coordination between two different applications or components or services, or have the consumers to coordinate and share the load from the queue. But for a stream, it stores data persistently, and you can have multiple applications consume the same data multiple times. So we actually have customers having 5, 6, 7, 8, 9, 10 applications consume the same stream. A classic example is for companies who have a centralized team to manage their data pipeline. So all these different systems within the company, customer management system, customer service system, HR system, all these new data gets collected into a centralized stream. On the other side, you might have multiple teams within your company who are interested in these kind of data for their different use case and business case. So you might have multiple consumers who wants to consume the same data. So this way you have a stream system sitting in the middle so that your consumer and producer, the folks who are generating the data and for the folks who are consuming the data, they are isolated because you have a single centralized system to manage all these data. So you don't end up with 500 different data pipelines routing data across different systems. It's super complicated, not scalable, and not easy to manage. But a streaming system allows you to do that. Have a centralized data storage location, real-time access, having multiple applications, doing real-time analysis, dashboard, or just simply ship the data into these different destinations that you use today. Next one is real-time aggregation. As I mentioned, this is not one of the use cases we would expect the customers to use Kinesis Analytics for, which is why you probably figured we named it Kinesis Analytics. But actually one of the popular use cases our customers use for Kinesis Analytics for real-time data aggregation. We have a customer and it's a particular team just manage the data pipeline, and they have a different team manage the data warehouse. They use Redshift. And they have another team, so there's like really 3 teams. The team who's generating the log data, that's one team. The engineer writes the application to generate the log data, push that into the Kinesis stream. And there's a second team who manages the stream pipeline. There's a third team manages the Redshift data warehouse. So one day, the Redshift team gets really blown up because they're writing terabytes of data every minute, because simply the applications are generating a lot of data. And apparently the Redshift cluster needs a lot of storage, has a lot of cost, and a lot of the time these data are not required because you can do some aggregation to reduce the volume of the data without sacrificing the insights you want to get out of your data. So this customer actually put Kinesis Analytics in between, does a very simple thing. It'll aggregate your log data from your original service or system before having Firehose push that into Redshift. So they reduced their data volume by more than 95% on Redshift without sacrificing the insights the data science team wants to get out of it. So huge cost saving for them. And it's a simple use case. You just write a simple SQL query on Kinesis Analytics and have Firehose push the data into Redshift. You get near real-time access, huge cost saving on Redshift. Logman notifications. So for the previous example that I gave, they all involve a human being to look at the data and gain insights and figure out what to do. So anytime a human being is involved, we're talking about minutes latency unless you're like Superman. But in some use cases, people actually need seconds or maybe even milliseconds latency. And that job cannot be done by a human being. You gotta have to be able to collect, analyze, react to data. Everything should be done using computer programs, not a human being. A classic example is in a lot of financial companies, a lot of trading data, they are generated in real time. And in the financial trading segment industry, how fast you can get these transaction data, analyze them, figure them out, is key to their business. So in these cases, the latency requirement is really milliseconds. So you can actually, using Kinesis services to ingest the data with milliseconds latency, having the data analyzed using Kinesis Analytics or your own applications, then trigger a function, trigger an application to do something right away without even involving a human being. Similar to the example that I gave before. When the pipeline identifies a particular web server that is having issue, the first thing you do is trigger a function to bring that server out of your fleet so that your customers no longer see that 500 error before you page or call a particular operator. So in this case, you can actually use, for example, Kinesis Analytics, detect anomaly. For example, what you can do is, say an IoT case, you have a lot of temperature sensors in the farmland. And you have these heating systems to heat up the temperature. So at a point of time, you might have an anomaly in your temperature saying, hey, the temperature really looks pretty strange, pretty weird. Maybe the heating system is malfunctioning. So the first thing you want to do before you call somebody or send an email to somebody is maybe I want to shut down the heating system. So in this case, you can use the Lambda function, just say, hook it up with your heating system, shut it down first when an anomaly is detected. Then at the same time, using SNS or CloudWatch, send a notification to the operator to come take a look at it, what has gone wrong. So these are some of the common patterns. There are a lot more. As you can see, we have a pretty big ecosystem using different tools, different capabilities, and third-party services or softwares. You can piece them together, do a lot of things for your business. So if you recall from the very beginning of the session, you got a pretty unhappy customer seeing 500 errors. You got a pretty frustrated engineer who couldn't figure out why and how to resolve the issue. You really want to leverage a real-time system to turn them into a happy customer and a pretty relaxed and happy employee. So if you want to do that, how would you get started? We got a homepage, just search for Amazon Kinesis. On the homepage, we have a lot of great content, give you an overview of these different capabilities, customer quotes, use case studies, what are they doing, why you should use us, pricing structure, and etc. We also have blog posts. These are pretty nice technical content I personally like a lot. This is just a centralized place for you to go read all these blog posts. If you want to kick the tire for a particular use case, there were quite a bit of blog posts about Kinesis out there for a particular use case that you can actually go look at the sample code, look at the step-by-step guideline as a starting point. We also have a getting started page with all the assets put together. We got blog posts, also video recordings from the past sessions. In case you have time when I take a look at it, we have lab course for you to get hands-on experience with Kinesis. So that's all there. So we have a lot of folks rush out probably for a sushi restaurant. So That summarizes everything I have to say today. Hopefully everybody gets something out of this session. Now we have about 10 minutes. I can open up for questions.